In this section, we're going to look at what the domain and range of a function are. So the domain is the set of the input values, or the set of the values of the independent variable, typically x, and the range is the set of output values, or the set of the values of the dependent variable, which is typically y. Okay, so we can examine the domain and range of a function in different ways. So the first way, we're going to look at a table of values. So if x is 0, 5, 10, and 15, when y is 10, 20, 30, and 40 respectively, we can say the domain just lists out those x values individually. We're going to use a set of braces to do that. So we want to write them in ascending order if they're not already written that way. So 0, 5, 10, and 15. And then the range the same way. 10, 20, 30, 40. If one value repeats, only write it one time. Okay, for a graph, if there's a finite number of points, like in our first example, you're going to just list out the x and the y values. If there's an infinite number of points, as in this curve, we have to write intervals instead. So using a ruler, run your ruler across the graph from left to right, and the first point that you encounter, we're going to write that x value down. So -3, and then my ruler crosses the graph every place until it gets to x equals 2. So the interval would be -3, comma 2, with a bracket at -3 since that point existed on the graph. But at 2 there was an open circle, meaning there's not actually a point at x equals 2, so we'll put parentheses. We'll use a similar technique for finding the range. Now I have a horizontal line that we're going to run up the graph. So starting as low as you can get, we see that the first y value, based on the first point that the line intersects, is -5. And then the last y value, okay, based on this maximum point of the graph, is 4. So the range is from -5, the smallest y value, to the largest one, which is 4. And both of those points existed on the graph, and therefore the y value should be included in this interval. So -5, 4 inclusive. And lastly, if we're given an equation of a function, we can often tell what the domain is pretty easily. So if it were a linear equation, like f of x equals 3x minus 4, I know that I could substitute any value of x into this function and get a corresponding value of y. So the domain would be all real numbers. A square root function is not the same. And so there are values of x which would produce non-real outputs or non-real y values, and they would not appear on the graph. And so we want to decide when that happens. Okay, so first I'm just going to find a value that won't work. So if I want to find f of 1, that's the square root of 1 minus 3, or the square root of -2, which is a non-real number. Okay, however, if we substitute 3 into the function, f of 3 is the square root of 3 minus 3, which is the square root of 0, or just 0. So 3 is a number that's in the domain. Okay, but to find those values, because there are still an infinite number of values, just set the radicand x minus 3 to be greater than or equal to 0 and solve this inequality. And we find that x is greater than or equal to 3. Interval notation, that would be from 3 to infinity with a bracket at 3. And based on the domain values of the function, we can find the corresponding range values. Okay, so we first substitute in an x value that we know is in the domain. Okay, so we have x equals 3. And we already found the corresponding y value, which is 0. Okay, let's try another. What about when x is 4? So f of 4 is equal to the square root of 4 minus 3, or the square root of 1, which is just 1. Okay, and we can continue in this manner and see that as x increases, so does y. And therefore, the range is from 0 to infinity.